So, what do we say? Space is a collection of all points. A line, it includes or contains all of the points that are on that line. All of the points that pass through it. A point, we say, lies on, or in the line. So, here are some little definitions. If we mess with these points right here, let's do that. Let's draw a line through the point T, this was T, and this was M, I think. All right. So we would say the points T and M lie on the line or in the line. So how do you represent this line? Well, we can do it a couple of ways. Here's one way we do it. You'll see it like this. Like, what if I call this C, B, D, E? If I call this line C. Well, you could either just say that this is called line C, or line B, or line D, or line E. Or another way you could represent these lines is say, here's a C, and on top of it you draw an arrow, a double-headed arrow on both sides. This means line. This means line B, line D, line E. So, what if it's passed through 2 points? How do we name that guy? Well, this would be TM with the double arrow, because the line goes on and on forever in both directions, and we'll call that, we say it expands infinitely in both directions. Also, since there's no kind of beginning or end to this line, if I were to say it passes through the point MT, that is also a way we could call this line. What if we decide we know another point on there and we call it D? Well, then, okay, there's just so many ways. We could call this TD. We could call this DT. We could call this MT. Oh, we already did. We call it MD. We could call it DM. All of these mean the same thing. They could all be called that line. So that's just a little notation of how you could call out points and lines. Okay, now, sometimes when 2 points lie on the same line, they are called collinear. So this is kind of a big word, so we want to make sure we give it a little bit of attention. Collinear goes like this. Just a second. So all that collinear means is that 2 points lie on the same line, or that points lie on the same line. So it turns out that any 2 points are collinear, and so I think that this will make a whole lot of sense, because if you draw 2 points, you can draw a line through them, and then they're collinear. So any 2 points are going to line up in a line. But if we've got 3 points, can 3 points be collinear? Well, that is, they have to be in the same line for them to be collinear. So if I was in point C here, if I put C up here, C is not collinear with A and B. If I put C here, now C is collinear with A and B. So let's look at this scenario, and then let's also look at this scenario, A, B, C. Let's look at this scenario. Let's see. A, C, B. All right, so to illustrate another new term called between. If we say that C lies between A and B, we are saying 2 things. One, that C is collinear with the A and B, with the line A and B, or the line that would pass through A and B, and we're saying that C is physically in between A and B. So, Does C lie, in this situation, I'll call this 1, 2, 3. Let's ask ourselves, is this true or false? C lies between A and B. Well, C is between A and B, but it's not collinear, so that does not meet this, what we are saying here. So for 1, the answer is false. This is false right here. For this one, C lies between A and B. Well, right here, C is between A and B, and it's also collinear, so this meets both of those, so we'd say that this is true for number 2. For C, for number 3, A, B, and C are all collinear because they're lining up, but C is not, I drew the same thing. Ah, darn it. This is what I meant to draw. A, B, and C. This time, we would say C is collinear with A and B, but C is not in between A and B, so this one would also be false. That's what I meant to draw at the time. So that is what the word, when we say between, what it means. Okay, now, let's see. Let's talk about line segments and length, and then this video will be all done. So segments are part of a line. Since lines go on forever and ever and ever, we have to cut them off in order for us to just talk about them, and that's called finite. When something's finite, it doesn't go on forever. So let's talk about a line segment. So of course we could draw a line through A and B here and it would go on and on forever, but let's just talk about this part of the line between A and B. This is a line segment, so that's good. Line segment. A segment of a line. Just part of it is all we're saying. Okay, so you'd have a line segment here. Let's just have a line segment here. Maybe we'll call this CD. All right, now, maybe I'll make this CD. So here are 2 line segments. Okay, so the length of a line segment is just the distance from the endpoints. A and B are endpoints, C and D are endpoints of that line segment, and the length is the distance between these guys. That's all that is. So, if it happens that this guy is the same length as this guy, we indicate that with a little mark. We might say, here's a mark, and we put the same number of little hash marks between there, and that means those guys are the same length. So, we could say, how you indicate the length of this line segment is AB. And you don't put anything on top. And the length of, let me say this, how I would indicate this line segment AB, the length of the line segment AB, this is what this reads, the length of the line segment AB. See, it doesn't have double arrows, I mean it's not going on forever, it starts at A and stops at B. And this is the same thing as BA. It doesn't matter if I started from BA, these mean the same thing, but the length of AB or BA, the length of it, is indicated with the letters without anything on top, and that means the distance between the endpoints, okay? So let's just pretend like this is 3. Then I would say this is 3. So if it turned out that this line segment CD, the length of CD, which we indicate by CD, by the way, we could also call that DC, that the order doesn't matter, but we said, oh, this is also 3, that's when we could put this little 1 hash mark between both of those. So very similarly, I could say here is some line segment XY. So this is XY. That means the line segment XY has endpoints XY. Okay. And let's just say that it is 11.3 units long. Well, then we would say the length of this is 11.3 units long. Well, let's say over here, there's some other line segment called WZ, and we measure it, and it turns out to be 11.3. Well, here's our line segment WZ. Say, oh, well, you know what? WZ, and again, you could reverse this. This could be ZW. Well, we could call this is equivalent to ZW. That means the line segment from Z to W, same, it's talking about the same little piece. Or we could call this ZW without anything on top. That means the length of it, how long it is. If we decide that that's 11.3, then we're like, oh, hey, you are the same length as you, and we could say, I'm going to notice that I'm going to put the same amount of hash marks through each. So when I see that, I know that these are equal in length. That is a little symbolism that we use there. Okay. Now, this is the last thing, so hang in there. We're almost done. What if I have to find the distance between 2 points? Okay. Sometimes we use a number line. So actually, the XY axis that I had up here earlier is just 2 number lines. It's one number line in the X direction and another one in the Y direction. So that's all that is. So if we just look at the regular, just the X axis, which is just a number line, right here, I think this is 0 and 1, 2, 3, 4, 5. This is -1, -2, -3, -4, -5. Alright, so this is just my number line. So way out here is positive infinity. That's what's way out here. And way out here is negative infinity, but those are really far away. Okay, so let's just put some points on here and then we'll talk about them. No. First, I want to say, have you heard of absolute value? And I bet you have. Absolute value is this symbol. They'll say the absolute value of X. And what absolute value means is how far a number is from 0. And we don't care if it's to the right of 0 or the left of 0. We just want to know how far away of it is. So if you have not had this yet, you will soon, but you probably have. What is the absolute value of 3? Well, this is how you figure that out. Here's 0, and here's 3, and it's 1, 2, 3 units away. It's 3. Or what's the absolute value of -3? Okay, well, here's -3, and here's 0, and here's how far it is between, which is 1, 2, 3 units. So turns out the absolute value of -3 is also 3. So absolute value is a distance, and distance is always positive. Okay, so now let's just name this point right here at -5a, at -3b, at 0c, at 3d, at 4e. Okay, now we have some points and a coordinate system. We're going to use whole numbers, but this same concept works when you have harder things like decimal points that are kind of ugly to look at. 1.7348, something like that. It's same concept works. So what if they say, here's a line segment, AD. How far apart is AD? How far apart, what's the distance between point A and point D? And that's what I mean. Well, how far apart is AD? Well, what you can do is you can take where A is landing and subtract it from where D is landing. So this is absolute value symbols, and this is a minus sign. So I'm going to put the value that A is, which is -5. I'm going to put it in parentheses. Minus, what is D? D was 3. So in my absolute value, I have -5 minus 3, which is the same thing as -5 plus -3, which is the same thing as -8. And how far is -8 from 0? It is 8 units away from 0. So turns out that A and D are 8 units apart. Now, these were whole numbers, and this was easy, and we could sit there and count 1, 2, 3, 4, 5, 6, 7, 8. We see that these are 8 units apart. But what if it's weird numbers that you can't count that easy? This concept still works. So let's go again. Let's see, what is the distance between B and E? Or even, let's do it backwards, E and B, which means the same thing. So all we're looking at this time is how far apart B and E are, okay? Well, let me erase this. So what I want to know is how far apart B and E are, and the order doesn't matter. So remember, it's going to be the absolute value of the first point minus the second point. So if I start at E, I'm going to put in 4. And then if I put in B, that's at -3. I put -3 right there. And this minus sign, remember, This minus sign belongs to the formula of how you calculate the distance. The distance between 2 points is the first point minus the second point in absolute values. So 4 minus negative 3 is a double negative, so this becomes the absolute value of 4 plus 3. So that becomes the absolute value of 7. And how far is 7 from 0? It is 7. So if we were to count from B to E, we go 1, 2, 3, 4, 5, 6, 7, and that works. So now I'm going to make it yucky. Let's make B not at negative 3, but negative 3.2. And let's make E not at 4, but at 4.5. Okay, just pretend like that's the truth. What is the distance from B to E? Well, it's going to be B minus E in absolute value. So B was negative 3.2, negative 3.2. And E was 4.5. So in this absolute value, I'm going to subtract 3.2 minus 4.5. And if or negative 3.2 plus a negative 4.5, and that would become a negative 7.7. So then oh, this is so big. Then I asked myself, well, how far, those don't look like 7s, 7.7. How far away is negative 7.7 from 0? Remember, I don't care if it's to the right or to the left. It is just regular old 7.7. So, we talked about points and space and collinear and lines and line segment and the distance between them, and I think that's plenty to get you started. See you later. See you blah 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 blah. See you later.